So in this question here, I'm going to try and find if this function here is continuous at the origin. So the function in question is 2xy over x squared plus y squared. Now I've got two techniques which I'm going to use. First of all, I'm going to use the method of limits, and I've got three kind of sub ways of doing that. And then the other method I'm going to use is the method using polar coordinates. So first of all, let's use the limit method. So first of all, I'm going to find the limit of this function here as x approaches 0. So the limit as x approaches 0 of f of xy, that becomes, to plug in a 0 where I see an x, 2 times 0 times y, 0 squared plus y squared. Now numerator is just going to be 0 and denominator y squared. So then that just becomes 0. So the limit as x approaches 0 is 0. Now let's find the limit as y approaches 0. So similar kind of deal as before. Where I see a y this time, I'm going to plug in a 0. So now I've got 2x times 0, x squared plus 0 squared. And very similar answer as before, 0 over x squared, which is just 0. So my limit as x approaches 0 and y approaches 0 are both the same. So that's looking promising. Now I'm going to use the limit along the line y equals mx. So if I let y equal mx, my classic linear equation, where I see a y, I'm going to plug in mx. And let's see what happens there. So now my f of x comma mx, that becomes 2x mx. And then divide that by x squared plus mx squared. Okay, right, let's just simplify this off a little bit and let's see what we can get this to become. 2x squared m, and then my denominator x squared plus m squared x squared. Okay, now not really conclusive just yet, but let's try and factor out this denominator, see what that becomes. So now I've got 2x squared m. Now take out the x squared, then I'll have a 1 plus m squared. Okay, now x squared and x squared will cancel. So now I'm left with 2m over 1 plus m squared. Now we'll see here that whichever path I choose is going to be dependent on the value of m, not of x and y. So therefore, we can say that this limit does not exist. So therefore, the function is not continuous at 0. So here, the limit does not exist. So therefore, the function is not continuous at the origin. Now I'm going to try the method of polar coordinates, see if we get the same result. Okay, now we're going to try the second technique, which is the method of polar coordinates. So now I need to just transform this a little bit, where x becomes r cosine theta and y equals r sine theta. Okay, now to transform that, just plug in r cosine theta and r sine theta where I see an x or a y respectively. So now my f of r cosine theta, r sine theta, that becomes 2r cosine theta, r sine theta. So just substituting in there. And then same deal with the x squared and the y squared, just square each of these terms. So now I've got r cosine theta squared plus r sine theta squared. Then we can just simplify this off a little bit. I've got 2 times r, so that's 2r squared. cosine theta sine theta. And then in my denominator, I'm going to have r squared cosine squared theta. And same here with the sine, same kind of deal. R squared sine squared theta. Okay, right. Now let's just simplify things off a little bit. Let's factor out the r squared in this denominator. So then I've got 2r squared cosine theta sine theta. Take out the r squared as that's common in both. Then I'm left with cosine squared plus sine squared theta, which immediately takes my eye as this is just going to become 1. So therefore, I've then got r squared on my denominator, which will also cancel out with this r squared in the numerator. So then all in all, I'm now just left with 2 cosine theta sine theta. So 2 cosine theta sine theta, we can see here that this is independent of r. So it only depends on the angle theta. So therefore, there's not a single limit for this function here, depending on what the angle is. So therefore, this function here does not have a unique limit. So therefore, it's not continuous at the origin. And that completes this question. Okay, thanks for watching.